Hello everyone. So from this lecture we are going to start real analysis, and in this lecture we will start with the first chapter, which is a countable and uncountable set. So let's start with the what we will read in this chapter. So first segment in this chapter we have the definition of a functions. Then we will discuss the one functions, and then we will discuss the onto functions. So I will distribute this chapter into three segments. So first segment is functions, one function, onto function, and the properties of this one onto function and some of the information. If there is a one function from A to B, then what we can conclude that. And second segment is a similar sets and their properties. And third one is countable and uncountable sets. So in each segment you will get a one test paper, and we will solve all the questions based on given theory. So let's start with the first segment. So what is the definition of a function? So function, so let A and B are any non-empty sets. So A and B are any two non-empty sets. Then a rule which is denoted by F from A to B is a rule is called a function. From A to B, if for every element of X belongs to A, basically F is a function from A to B if every element of A is assigned to unique element of B. That is, for all X belongs to A, there is a unique element B or Y belongs to B such that X is assigned to Y, that is Y should be same as Fx. So basically every element of A assigned to unique element of B, and in this case this Y is called image of X and X is called pre-image of Y, and A is called domain of function or domain of F, and B is called codomain of F, and this set F of A, which is a collection of all images F of X such that X belongs to A. So this is called a range of F. So these are some terms. So first, a function in which function is a rule in which every element of A is assigned to unique element of B, and this unique element Y is called image of X and X is called pre-image of Y, and the set A from which we have defined a function is called a domain, and the set B to which we have defined a function is called codomain, and the collection of all images is called the range of the function, and obviously F of A must be a subset of B. So these are basic meaning of the function. And next is the geometrical meaning of the function. So if we have A is a non-empty set, B is also non-empty set, assuming that A and B are a subset of a real line, and if we will represent A on x-axis and B on y-axis, and let's take an example. This is a curve of a rule y equal to fx. So f is the rule from A to B, and this one is the curve of y equal to fx, and let this x belongs to A. Then if we will draw the line parallel to B or parallel to y-axis, so this one say y1 point, and this point is say y2 point, and this point is y3 point. That is, f of x is equal to y1, again f of x is equal to y2, f of x is equal to y3. So x has three images, but in a function every element must have a unique image. So this curve is not representing a function. Another example, if we will take again a on x-axis, b is on y-axis, and say a is this interval, and if we will define this curve for y is equal to fx, and if we will take a point x belongs to a, then the line passing through this x and parallel to y or b does not intersecting at any point, that is, there does not exist any image of this x. So geometrical meaning for a geometrical meaning of a function, every element should has an image and the image should be unique, that is, every line passing through a and parallel to b should intersect the curve y equal to fx exactly once. If it intersect more than once, then it is never a image is not unique. If it is not intersecting, then image does not exist. So finally, definition of a geometrical definition of a function or rule from a to b is a function if every line passing through a and parallel to b intersect the curve y equal to fx exactly once. Next is how to count the number of functions from a set A to B. So let A is a set with n elements and B is a set with m elements. So task is a number of functions from A to B. So this one is our task is, so let A is something a1, a2, an. So A has n elements and B has m elements. So B set is say b1, b2 up to bm. Now we have to define a function. So in a function, if f is a function, then every element has image. So a1 can be mapped to b1, a1 can map to b2, a1 can map to bm. So number of choices for a1 is exactly m choices. Again a2 also can be mapped to b1 or b2 or bm. So again choices for a2 is again m, and similarly choices for an is also m. So obvious result, number of function is m to the power n. That is a number of element in b whole power number of element in it. So this one is an important result for a counting of a function from a given set A to B. Let's take us some of the questions on a function. Let A is equal to 1, 2, 3, 4 and B is equal to A, B, C and D. Then a number of functions from A to B such that f of 2 is equal to b and there does not exist any x belongs to A such that f of x is equal to c. So we have to count the number of functions from A to B in which image of 2 must be b and the pre-image of C does not exist. So basically we have A set, B set, and we have to define a function f. A has 4 elements 1, 2, 3, 4 and B has 4 elements A, B, C, D. Now image of 2 is already fixed, maps to B, and pre-image of C does not exist. So now we have to find the image of 1, 3 and 4. So choices for 1 can maps to A, 1 can maps to B or 1 can maps to D. And similarly 3 can maps to A, 3 can maps to B or 3 can maps to D. So for each these element there is exactly 3 choices. So definitely number of function is 3 to the power 3, which is satisfying this condition, because each element of domain has exactly 3 choices in codomain. So total number of function is 3 to the power. Let's take another question. If A has 1, 2, 3, 4 elements and B has 3 elements A, B, C, then number of functions from A to B such that at least one element of B does not have pre-image. So we have A with 4 element, B with 3 element, and we have to find number of functions from A to B in which at least one element of a codomain does not have a pre-image. So how to count these functions? So now if A has 4 elements and B has 3 elements A, B, C. Now first situation, the number of function in which A does not have a pre-image. This can be the first case because at least one element does not have a pre-image. Similarly, second situation is A 1, 2, 3, 4 and B is again A, B, C and B does not have a pre-image. And third case is again A is 1, 2, 3, 4 and A, B, C and C does not have a pre-image. So we have to count the number of function in which at least one element does not have a pre-image. So first we are counting the number of a function in which A does not have a pre-image, and then number of function in which B does not have a pre-image, and number of function in which C does not have a pre-image. Now if we will define number of function from A to this B comma C, so there are 2 to the power 4 functions. So in this case there are 2 to the power 4 functions in which A does not have any pre-image. In this case again 2 to the power 4 functions in which B does not have any pre-image, and in this case again there is a 2 to the power 4 functions. Now out of these 2 to the power 4 functions there is a function in which all elements maps to B, and there is another functions 1, 2, 3, 4 and A, B, C. A is already excluded and we can map all element to C. That is, in this counting 2 to the power 4, these two functions are already counted. And these are function in which A and C does not have pre-image, and this is function in which A and B does not have a pre-images. In this case, we can define a function in which all elements can maps to A, and another function 1, 2, 3, 4, and this A, B, C, all element can maps to C because B is already excluded. So in this case, these are function in which B and C does not have pre-image, or A and B does not have a pre-image. Now this case, or this function and this function is the same function. That is, in this counting and in this counting, we are counting this function 2 times, in which A and B does not have a pre-image, but we have to count only once. Similarly, if we will take this one, we can define a function, all elements can maps to A, another is 1, 2, 3, 4 and A, B and C. C is already excluded, we can maps all element to B. So in this case, this is a function in which A and C does not have a pre-image, and this is also a function in which A and C does not have a pre-image. So this function and this function is the same. Similarly, this function in which B and C does not have pre-image, and this is also B and C does not have a pre-image. So this function and this function is same. So whenever we are counting the number of function in which one element does not have a premise, either A does not have premise, or B does not have premise, or C does not have premise. So there are another function in which two element does not have premise, and these functions are counting twice. So we have to count the number of function in which exactly or at least one element does not have a premise. So starting we have to count number of function in which A does not have premise, and then we have to count the function in which A and B does not have premise, A or C does not have premise, or B or C does not have a premise. So initially, whenever we are counting the functions in which A does not have a premise, these are 2 to the power 4, and B does not have premise 2 to the power 4, and C does not have premise again 2 to the power 4. So this can be written as 3C1. Out of these three elements, we can take a one element, either A, B or C, whose premise does not exist, and from remaining function there is exactly 2 to the power 4 function. So this is a number of function in which at least one element does not have a premise, but in this case we are counting these functions twice. That is, the function in which two element does not have a premise, that we are counting two times, so that we have to subtract in which two element does not have premise. So 3C2 representing either AB does not have premise, AC does not have premise, or BC does not have a premise. If A and C is already excluded, then there is only one function, or we can write down 1 to the power 4 function. So in this calculation we have counted number of function in which A does not have premise, B does not have premise, and C does not have premise. And since this function counted at 2 times, so we have subtract once, and this function is counted at 2 times, and we have subtract once, and this function is also counted 2 times, we have subtract 2 times. So this one is a number of a function in which at least one element does not have a premise. And the last concept, whatever we have discussed, we can generalize to in general set. So if we have A with n elements and B with m elements, then number of functions from A to B such that at least one element of B does not have pre-image. So thus we can write down first the number of elements. Since A has n elements, so A1, A2, An, and B has m element B1, B2, Bm. So first we have to count the number of function in which B1 does not have a premise. Secondly, B2 does not have premise, and Bm does not have premise. So from m element we have to choose one element. From remaining element there is a number of function which is m minus 1 to the power n. And in this calculation, the number of function in which two element does not have premise, that will counted 2 times. So we have to subtract that value. So mc2 into m minus 2 to the power n. In this counting, the number of function in which 3 element does not have a premise, that subtracted 2 times. So we have to add that value. So mc3 m minus 3 to the power n, and so on. So this is number of functions from A to B in which at least one element does not have a premise. So this one is